Alrighty, welcome back, folks. Let's go ahead and take a look at 46 through 50. 46 reads, a 10-inch tall plastic model weighs a certain amount, 2.78 pounds, and a real statue is 9 feet and 5 inches tall, which is made out of granite. How much does a real statue weigh? And they also tell us that there's this density here. So the setup for this is, again, keeping track of proportionalities. In this case, they're giving us weights and lengths and something about densities. Well, going back to some chemistry and physics, we recognize that weight is equal to mass times gravity, or acceleration due to gravity. And the weight's going to be proportional to the mass, since we're doing this probably on Earth in both of these scenarios or both of these statues. And mass itself is equal to density times volume. And volume itself is proportional to length cubed. So that's kind of the big connection here. Putting this together, we get that the weight is proportional to density times length cubed. And to keep the proportionalities constant, we're going to divide them over, and then we can set them equal to each other. What does that mean? So the weight divided by density and length cubed, that's going to be the same for both statues. So weight 1 over density 1 times length 1 cubed equals weight 2 times divided by density 2 times length 2 cubed. And here's the setup. 2.78 divided by 1.38 times 10 cubed. And then the tricky part here is, remember that the height of the other statue includes feet, so you convert that part to inches, you add them up, and you find out that the total weight of the other statue would be 7.7 times 10 to the 3-ish pounds. 47, linear regression. We're going to do this into our stat register. The electrical resistivity of copper at 100 degree increments between 300 and 700 are as such. They want us to find out what is the best percent error in the best fit value of the resistivity at 1300 if the exact value is 31.08 micro-ohm centimeters. So thankfully here we can see that they don't tell us anything about the proportionality. We can assume that it's linear or direct. So start punching in the numbers. In this case, the resistivity, one can assume, depends on the temperature. So that's going to be our Y value. 12.9, enter 300 sigma plus, right? Make sure you've cleared your stat registers, because you use the linear regression questions, right? Or the function in the previous question. Then 14.6, enter 400 sigma plus, 16.6, enter 500 sigma plus, 18.5, enter 600 sigma plus, 20.3, enter 700 sigma plus. And that's because the temperature is going up in 100 degree increments. The last thing is, we want to predict the value at 1300 Kelvin, so 1300. We push linear regression function on the calculator, and then we have it predict the Y value. That's going to be the estimate value. From there, we're going to do a percent error calculation, and our calculator, again, does this through the percent change. The important thing to remember is that the first value in that function needs to be the exact value, which is the 31.8. So after you have the predicted value from linear regression, press enter, load it into the calculator. Then type in 31.08, swap the two, so do the XY swap button, and then now you can do percent change, and then there's your answer. 48 is a solver. Make sure that we get a chance to do these on the calculator test. Easy points if we are going past question number 45 on the crunchers. All right, number 49. 49 gives us the volume of these two shapes, a cylinder and a square pyramid, equal to 422. So the idea is the total volume of this shape here is going to be the volume of the pyramid plus the volume of the cylinder. The volume of the cylinder is the base area times the height, pi r, times, in this case, they want us to find the diameter. So the diameter would be x, and the radius would be the diameter cut in half. So we're going to write that as x over 2 in parentheses, quantity squared. Happens to have a height of 4.74. And to that we're going to add the volume of the pyramid, Now the volume of the pyramid, I messed up. For tapering objects, they happen to be 1/3. So it's going to be 1/3 the base area, which is going to be a square. And we don't know the side length yet, but it would be, we'll just call that S times S, or S squared, times the height, 9.51. Now the tricky part is, how do we get the side length? Especially because they want us to get the diameter. Well, the challenge here is that we need to write the side length S in terms of the diameter. And the way we're going to do that is, if we draw a picture or we look at it from the top, we have the cylinder at the bottom, which is the yellow circle, and the square. If we look at it just right, the tips of those square bases touch the edge of the circle. So it turns out the diagonal of that square is going to equal the diameter. And we've talked about the diagonal of a square and in how it's equal to the side length. It's going to be the side length times square root of 2. So S times square root of 2 is equal to the diameter, which we're calling x. And we're going to want to write the side length in terms of diameter, so that when we substitute it into the big equation, our solver can solve it right away. So putting that together, 422, man, I really messed up, equals 1/3 the base area, x over square root of 2 quantity squared, because that was the radius. Sorry, the side length in terms of the diameter, not radius, times the height, plus pi times the diameter cut in half squared times its height. Throw that into your solver and we get us diameter of 8.31. Number 50 is another seemingly intimidating problem. Now, if they ever ask for some quantity over a variable, a lot of times the easy solution is make that other part of the variable, sorry, I was lowering my chair, make that unknown variable equal to 1. So in this case, you could say that this a here is 1, and the side length here is going to be 1.7. But let's go ahead and say you didn't know that. They want us to get the volume of this shape, which is a truncated cube, divided by the volume of a cube of side length a, but be careful here. They don't want us to divide by the length here cubed. They want us to get divided by this side here cubed. So how do we do this? Because this is a weird shape. Well, part of the challenge to these questions is being able to build up the solution. So it turns out that if we took the volume of that cube and we took out that chunk, that would be the volume of that shape. And the volume of a cube would be side length cubed, which here I wrote as a, but be careful, I really mean a cube of length a. Cube. Alright. Well, how do we get this chunk here? Turns out that it's kind of like a triangular prism, or a triangular, not even prism, sorry. A prism would be triangular on both sides, but it tapers to a point. So this is a triangular pyramid, an irregular one at that. But it turns out that its volume is really straightforward. Again, I keep mentioning this, that if you want to get some kind of size, like area, you take a length times a perpendicular distance to it. Length times width. And if you want to get volume, take an area, and you multiply that by a perpendicular distance perpendicular to it, which we often call height. So the volume of this chunk, because it tapers to a point, tapered points, a nice thing to remember is that they have a 1/3 factor in them. So it would be 1/3 the base area times the height here. Now how do you calculate this base area? Depends on your preference. One way you could do that is recognize that, hey, this looks like a triangle right here. Let me call that the base. So the area of that base would be 1/2. This length, 1.7a, times this height, 0.7a. And then that would be the area of this blue section here. And we would have a perpendicular distance, or a height, of this pyramid of 1.7a. Putting all that together, The volume of this chunk would be 1/3 times that base area, which would be 1/3 times 1/2 times 1.7a times a, sorry, 0.78. We missed a 0.7a right here. Because if we look here, the base area, 1.7a, would be this distance here. 0.7a would be this distance here, and then that would be 1/2. And then times the height of the pyramid, which would be this distance right here, 1.7a. When we multiply all this through, we get 1/3 times 1/2, that's a 1/6. 1.78 times 1.78 comes 1.78 quantity squared, times a times 0.7, because I forgot that part. I apologize for that sloppiness. But that would be the appropriate volume of that. Now let's say you happen to consider the top portion here as the base area. Well, that's still another triangle. And its area would be 1/2, and it would have a base length of 1.7a and a base height of 1.7a. And then technically the height of that pyramid would be in this direction here, and that would be 0.7a. Putting it all together, the volume of that chunk, if we went this route, would be 1/3 times 1/2 times 1.7a times 1.7a times 0.7a. Man, I keep forgetting that. And hopefully what we recognize is, regardless of how we get the volume, we get the same expression, 1/6 times 1.7a squared times 0.7 times a. Anyways, we take all that gigantic expression and we put it in here. Now this question may not be worth the time, but let's keep going. So they want us to get the volume of that shape over a cubed, which is going to be going back over here. Oh my lord. Right over here. The volume of the shape would be the volume of the cube, which would be 1.7a. I am sorry, I got a little arrogant and thought I remembered the exact question, because they tend to ask it usually in terms of the side length cubed, not a cubed. And usually that side length cubed is just that number. So anyways, it's going to be 1.7a quantity cubed minus the volume of that chunk, 1.6 times 1.7a quantity squared times a times 0.7. That is the total volume of the truncated cube divided by a cubed. And the nice thing is that all these a cubes cancel. If you set them to 1, the result is still the same. Now 1.7 cubed is going to be a number that I don't have the number sense for, and I really think I should, because I think you're expected to know your cubes up to like 20 in number sense. But the true answer becomes 1.7 cubed minus 1/6 minus 2.89 all over 1. So yeah, this part is a little incorrect. 1.7 cubed. Alright, so that's the way we do this question. I apologize for the sloppiness of the solution. I really thought I had laid it out correctly, but that one big mistake propagated itself everywhere. I hope I caught it in all the explanation portions, and we were able to keep up. Alright, let's continue. Oh wait, no, that was the last one actually, right? Yeah, 50. So, thank you.